Hi, I'm Jerry and I'd like to present Semantic Draw to a real-time interactive content creation from Image Diffusion Models. Let's say we want to create a piece of artwork like this. Now imagine drawing it by simply selecting some regions and typing in short text prompts. This is the task we're interested in, enabling content creators to rapidly prototype their ideas using only a few words. Previous methods for multi-prompt image generation fail to scale in practical settings, although they perform well with limited prompts. They require nearly an hour to produce an image at this scale, with their consistency very much damaged. While acceleration techniques like latent consistency models reduce runtime, they tend to break the output quality, and this incompatibility between acceleration and control hinders real-world application of both techniques. Our semantic draw overcomes this through a general model-agnostic pipeline augmentation, in order to not only achieve fast generation speed, but also gain stability and consistency. We establish compatibility between region-based control methods and accelerated diffusion schedulers, enabling up to 50 times faster multi-prompt image generation without sacrificing any quality. To maximize throughput and minimize latency, we introduce a novel multi-prompt stream batch architecture, achieving sub-second interactive generation. This powers a new paradigm, which we call Semantic Draw, a general model-agnostic framework for real-time, high-fidelity image creation from semantically labeled regions. Our method addresses two key challenges for interactive generation, ensuring compatibility between region-based control and acceleration modules, and maximizing generation throughput. We'll start from general diffusion model pipeline. We separate foreground and background mask by masking the common latent tensor using a set of user-defined masks. In our scenarios of accelerated diffusion, masking has a chance of breaking down the overall structure, so we prevent this by mixing masked foreground contents with white background. This is called the bootstrapping stage that happens in the first 2 or 3 steps. Diffusion models trained with natural images have a strong tendency to put its main contents at the center of the screen. In a few-step generation scenario like ours, this object-centeredness bias breaks the off-centered foreground objects. This is alleviated by centering its foreground mask separately with its mask center before handling to the denoising model. We restore the offsets after denoising step. Finally, to support both Euler type and Langevin type schedulers, we defer noise addition step of these schedulers until after the merging is completed. Our augmentation of diffusion pipeline is agnostic to both models and schedulers. In order to maximize the throughput, we pipeline the overall generation process by aggregating latent across different time steps into a single batch. For each step, we sample a random latent and then attach to the previous batch of intermediate latents. After passing through the denoiser, the last frame is decoded into the new set of images. This allows us to hide latency and convert it to throughput, enabling near real-time generation, making interactive content creation truly responsive. We additionally cache the redundant part of the model to optimize user experience. Our approach enjoys the speed-up benefits of acceleration models while preserving output quality. It is fully general and can be applied to any large-scale diffusion pipeline. As demonstrated, our method not only accelerates generation but also improves mask consistency and visual harmonization. By ensuring compatibility between control and acceleration techniques, we provide a practical high-fidelity solution for multi-prompt generation, agnostic to the underlying diffusion model architecture. Our multi-prompt stream batch architecture enables sub-second generation, and this leads us to make real-time application, which we name Semantic Draw. In this application, users can interactively paint with text prompts using familiar brush tools with near-instant feedback powered by cached embeddings. It also supports fine-grained controls, such as mask transparency and blur, for precise and consistent editing experiences. In conclusion, we believe powerful tools like diffusion models deserve entirely new form of applications to truly realize their potential. New wine needs new wineskins. We have also released our code and interactive demos, so if you find our work interesting, we invite you to explore and try them out. They're quite fun to play with. Thank you for listening.